Hello, nice to see you.
Hi everyone. Can you hear me?
Yes, video is good, presentation is good, and your voice is good. Please go ahead.
Uh, Thank you very much. To clarify, we are a team working on ecogvideo data instead of the hand post data. There might be some change at the very beginning of the hackathon, but then we are focusing on the ecogvideo data instead. We are a team consists of three people. I'm from Canada, machine learning engineer, and then we have a researcher from China and also an undergraduate student from Houston. So the work that we were doing is looking into a previous work, which is the ECOG video watching paper. And basically, we receive a data set, which is the video and also the corresponding ECOG data. So the entire research question or the target that we were trying to achieve is to try to figure out whether or not we can replicate what this paper mentioned, that the ECOG data did differentiate different kinds of triggers or targets, and can we replicate the same thing by looking at the ECOG data of our subject in when the data is exposed, the subject is exposed to all these different kinds of subject in different kinds of targets in the video. So the main idea is how we can prepare a data set that can allow us to do that is to first go with the labeling. So we extracted the frames of the videos, and then from the onset of a particular target is presented, we extract the 600 milliseconds after the onset, which correspond to around 720 frames. And then basically for each of the targets, we have 700 or so frames. That would be the entire sample for us to classify that particular class. And we also plot the data out to get a rough idea, but that didn't give us a lot of insights. So in terms of the solutions, we basically follow these four steps for our pipeline. We go with data labeling. First go with manual labeling because we want to have a very high resolution of the timestamp. So we actually go with a video player and then go actually pick which part or which particular timestamp is the timestamp where the target presented as the onset. This is pretty tedious, and then it took us quite some time, and we then tried something which is the automated labeling that I will talk later. We also, one of our teammates work on the pre-processing steps by applying most of the filters or processing algorithms that the paper mentioned. And then after that, we got the data, which is around 27 samples. Then we do some ML by trying out different classification methods. And eventually we try to evaluate what's the most important features. So the very first we have three main takeaways. The very first one is about data labeling. So as I mentioned, this is a data that is not something like show on a screen where the targets are presented somewhere in the video where we really need to label the timestamp. That's taking quite a lot of time, and it is not particularly accurate as well, because when there are multiple targets showing at the same time, like a person holding a toy, that's kind of hard to actually give it a one-hot label. So as a person coming from the ASR or like general machine learning background, I do want to find out if there's any way to fasten this process or make it a little bit more automated so that people in neuroscience might be able to go with a much larger scale of data collection process. So one thing that we try is to use the CLIP model, which would basically identify the activation or softmax of particular trigger or target in the whole video. So as you can see, it actually labels, let's say for this part, it is something like a kanji presented in this part, a face presented in this part, and so on. So this will allow researchers to get labeling much faster, likely. Then the second part is about classifier. We try a little bit on three kinds of classifier: KNN, random forest, and XGBoost. I would say because of the small data set, the test results might not be very accurate or representative, but at least it shows that it might be doing something. And the very last part is about channel or feature contribution. So one of our team may look into which channel actually contribute to classification results. And then it turns out that there for different kinds of targets, different channels has different level of contribution. And there are some channels which has higher correlation and also higher contribution, mainly 97, 148, and 141, and so on. And then we look into which part of the brain that those signals are coming from. And it seems that by reading through some literatures, these are some areas of the brain which focus on brain or on face or on locating like words or whatsoever. So it seems to match align with existing research, and that's what we learned so far. And I guess that's all I have for a presentation. Thank you.
Thank you very much for the presentation. Camille, you're also here now. Can you come online? Do you hear us? Camille? Hello? Not reacting at the moment. So what do you think, how many different commands are you able in future to discriminate with such a setup? Any guess?
Sorry?
How many different commands are you able to distinguish with such a setup? Any guess how many different things you could discriminate in the video?
So at the moment we're doing like 7 things, but I can totally see there's some other items that we can add into it. Like for example, the glass and tree background is something that not clear to identify, but then we can basically utilize all the softmax layer of our image classification model and then kind of train on top of those output labels. So just whatever like image classification model can identify, we can kind of use those as soft labels.
Okay, thank you very much. Very nice approach.